I want to review what we have been doing. Vertex and roots usually are two very different things. Occasionally you'll come across a parabola where the vertex and the root are the same point, but that's not normal. You got to be good at finding both of these things. So let's talk about how you find them and what they are. Vertex of a parabola is either the very highest or the very lowest. Okay, so number 1, I don't know what it looks like, but I know it's some kind of smile. So for number 1, my vertex is the minimum. If you were looking at a frown, then your vertex would be the maximum. Like number 2 is some kind of frown, and the vertex is a maximum. Now, how you find the vertex, no matter what kind of vertex you're looking at, the way we have learned so far is a combination of your brain and your calculator. First of all, the vertex is a point, and a point is an x number and a y number. The way we learn to find vertex is you find the x value with your brain and your pencil and paper by doing the opposite of b over 2a. Then to find the y, you turn to your calculator. Specifically, you look at your t-chart and look across from your x value, and that's the y that goes with it. So vertex is a point. You come up with the x, and it's super easy to do that. Then your calculator, when you look at the t-chart, will tell you the y that goes with it. Now, roots are completely different. Roots are not the top or bottom of the picture. Roots are the x-intercepts, the zeros. To find roots, that's where the function actually equals 0. That's where the y value is a 0. That's why they're called zeros sometimes. So to find roots, you do something different. You can do it completely in your calculator. We learned how to factor. We learned how to use quadratic formula. From here on out, I say use your calculator. But you got to be careful about how you do it. You got to remember how to do it. You want to go to y equals. First, you put in your function rule, and then you also put in y equals 0. Y'all remember this? And then you see where you calculate where they intersect. And it's going to ask you first curve, second curve, guess, and then you should see the word intersection, and it should have an x number for you, and the y number should be a 0, because that's what these are, zeros. Your calculator will tell you one at a time, so once you find one of them, then you've got to hit the trace key and hit the left or right arrow, get over to the other side, and find the other one. You do the same thing again. Second function, calculate, intersection, enter, enter, enter. And it'll tell you the other root. So two very different things and two very different ways to find them. And you must know the difference. You must be able to do both. Okay, so for vertex of this guy, the opposite of b, well, b is negative 8. What's the opposite of that? Positive 8 over 2 times a, and in this problem a is a 2, so opposite of b over 2 times a would be 8 over 4, and 8 over 4 equals 2. Now that's only part of my vertex. What part of the vertex did I just find? The x. The second part is what y goes with it, and now my calculator will help me. I go to y equals. I must put in the function rule. 2x squared minus 8x minus 6. I tell my table to start at 2. I go to table set and tell it to start at 2 because that's my x value that I know. Then I look at the table of values. Whatever's across from 2, that's the other part of my vertex. So what's the vertex of this thing? The whole vertex is 2, negative 14. Remember, vertex is a point. And if I asked you to, you could tell me whether it's a minimum or a maximum. This has got to be a smile. First of all, I can look at it in the calculator. The vertex is down here somewhere. It's not quite showing. It's at positive 2, negative 14. It's kind of off the screen. It's definitely a minimum. Are we good with that? What do we still have to find? The roots. Okay, let's look at this. Sometimes you don't have roots. It's always a good idea to look at your picture. Do I have roots? Absolutely, I have 2 of them. Roots are the same thing as the x-intercepts, otherwise known as the zeros. So I'm going to go to y equals and make sure I also have y equals 0. This is not going to work if you don't put in y equals 0. and we're going to calculate where they intersect. My cursor is over here on the right. It's going to give me, this is going to be a positive answer. I can tell because it's in between two positive numbers. So it's asking me first curve, second curve, guess. Please don't stop till you see this word intersection. And it's not a nice whole number. It's a yucky decimal. How many places did I tell you to give me? Right, so I would write 4.645. What's the y value that goes with that? 0, because these are what? What are these called? Otherwise known as zeros. They're called zeros because it's when the y value is a 0. You can just put x equals. Absolutely. Now, how do I get over here to this one? Hit trace, and then do not go up or down. You want to hit left or right. I need to go to the left until I pop up over there on the other side, closer to this 0. Doesn't have to be right on it. It just has to be over here on this side. And then I do the whole thing again. I want to calculate intersection. Second function, calculate where these two functions I entered intersect. First curve, that just means first equation pops up. I hit enter. Second curve means my second equation I put up pops up. I put enter. Please don't stop at guess. Some kids stop right there and write this down without even looking. Don't stop until you see the word intersection. What's the other 0? Negative 0.645. And if I asked you to write it as a point, you would also write comma 0. Or you might just see it as two separate x values. X equals 4.645. X equals negative 0.645. You can write it like that. Sometimes you see set notation. 4.645, negative 0.645. Why would I not want to use parentheses? Yeah, you don't want these guys to look like they are a point together. They are not a point together. They are two separate x values that make two different points. Okay, let me back up for a second. Let me show you a trick that I saw one year on the end of course exam, and it made me so sad because some kids fell for it. They gave a problem like this and asked to find the zeros, and choice A, look what these sneaky guys did. And they made it choice A. And some kids saw the numbers that they got out of their calculator, and they picked choice A. What's wrong with that? Yeah, this is the X and Y. They switched them around. These are not Y values. These are X values. If they had kept looking, hopefully they would have seen, and they didn't put the right answer till all the way down at choice D. It shouldn't look like this. It should look like 4.645, comma 0 and negative 0.645, comma 0. So please be careful. They will try to trick you. Don't let them. Here's another thing you might be asked. They could give you a function like that, and they won't ask you for both roots. They might ask you, what is the positive root? Because this one happens to have two roots. One of them's positive, one of them's negative. So if they only ask you for the positive, which one would you give me? This one. But guess what they're going to put down there? They're going to put down this one, and some kids will not read carefully that it said they wanted the positive one, and they're going to see an answer that they recognize and pick it. This is not the positive one, that's the negative one. So just be careful. Read the questions very carefully. Okay, so we found vertex and we found both roots. Have you guys done this one? If you forgot how to do it and I just refresh your memory, real quickly try to do this one. I want vertex. I want roots. And ladies, if you came in late, try to grab somebody's homework and grade your homework real quick. Somebody around you should have 100. Before I do anything with a parabola, I usually go to y equals, enter the function rule, and I just take a look at it. First of all, it gives me a good estimate of where the vertex is. And there's something else I should recognize from this picture right away. It doesn't have any roots. How can I tell it doesn't have any roots? Yeah, it's never crossing the x-axis. It's a frown that starts under the x-axis, and these arms go down forever. They're never going to cross the x-axis. And the vertex should be somewhere around -1, -2-ish, just from looking at it. I don't know the exact till I figure it out, but I can kind of get a good idea just from looking at the picture. Let's see exactly what the vertex is. Half brain, half calculator. You find the x, calculator finds the y. The x is found by doing the opposite of b over 2a. which would be positive 2 over 2 times negative 1, which is negative 1, which is kind of what it looked like on the picture. How do I find the y that goes with it? I tell my table to start at negative 1. I go to my table of values, scroll over. What is my whole vertex? Negative 1, comma, negative 2. That's my vertex. A vertex has to be a point, an x number and a y number. And here's something else I can do. If I kind of put the vertex in the middle of the t-chart, just to double check myself, you should start seeing y values repeating each other around that vertex value. Do you see what I'm talking about? It's because that vertex is right in the middle. Alright, that's my vertex. Now, pretend like I didn't look carefully at the picture. I'm just plugging along, doing my problems, not really thinking. I'm trying to find zeros now, and I know that means I have to put in y equals 0. And I'm going to calculate where they intersect, and I try to get my calculator to tell me what's going to come up. Error, no sign change. Does that mean I made a mistake? No, because it doesn't have a go-to option. It's trying to tell me something. What's it trying to tell me? Yeah, there are no roots. It's saying go back and look at that picture again. If we looked at the picture carefully, like we did the first time, we should have seen there were no roots. So my vertex was negative 1, negative 2, and in this case, there were no roots. Alright, today we're going to add one more little thing. Now, tomorrow, we don't have very many grades, guys. We've been back from Christmas for 2 weeks, and I've seen you, what, twice? No, how many times did I see you last week? 4 times? 3 times last week and once this week? We've got to get some grades. So I could give you one of these and ask you for one thing at a time. I'm not going to ask you for all things on all questions, but I could give you this and just ask you for the positive root. I could give you this and just ask you for the vertex. Okay, so you got to know what each thing means and how to find it, and we could have a quiz as early as tomorrow. Now, I just did roots. Okay, you go to y equals, you enter the equation, you also go to y equals, and you have to put in y equals 0. If I ask you to find roots, I want you to think in your mind, that means zeros. That means I have to put in y equals 0. And then you just calculate where they intersect and hit enter, enter, enter until it says intersection. But what? Tell me. Go ahead. Finish your thought. Still don't get it? Alright, now, we're adding one more thing today called access of symmetry. And it's super easy, folks, because we pretty much already know how to do it. Access of symmetry is so closely related to vertex that we really already know how to do it. I just didn't want to throw too much stuff at you at once the day that we did vertex. So it's a pretty simple concept. It's really easy to find, and I'm going to show you how they might ask you some questions about access of symmetry. What do y'all know? What does symmetry mean? Identical, yes, the same. I think of it as like a mirror image. It's like when you see the same thing on both sides of the mirror. Okay, so this is where it's right through the middle of your graph. What other thing is right in the middle of the graph? Well, the origin's in the middle of your blank grid, but let's say this was my graph. What else is in the middle of a parabola? The roots aren't necessarily in the middle. What? What's in the middle of every parabola? The vertex. The vertex is right in the middle. So the axis of symmetry is also right through the middle. It's right through the vertex. So let's define what axis of symmetry is. Axis of symmetry is just a vertical line. It's an imaginary line, but it helps us find points on parabolas. It's a vertical line that passes through the center of the parabola. And if it's going through right through the center, that means it has to go through the vertex. So we find it very similar to how we find vertex. The only difference between this and vertex is axis of symmetry is not a point. It's a line. So you don't write it like a point like you do for vertex. You write it as the equation of a line. So keep that in mind. Equations of lines must have what in them? Equations of lines must have what? Equal sign. They have to have an equal sign. It's not a point, it's an actual equation. Let's just review what we know about vertical lines. I'm just going to draw a vertical line right here. Okay, and I know it's not perfect. Pretend it is. That's a vertical line. You should be able to tell me the equation of that vertical line just by looking at it. X equals 3. We did this before Christmas. This is x equals 3. That's the equation of this line. Why is it x equals 3? Because every x value on this line is a 3. No matter where I fall on this line, the x value is 3. 3, 0, 3.5, 3, 1, 3, 2, 3, 3. Do you see how all the x values are 3? Now, if I asked you to give me the equation of this vertical line and you tell me 3, guess what I'm going to tell you? Wrong. That's not an equation. That's a number. You have to have the x equals. You have to. All right. What's this vertical line? X equals 1. X equals 1. What's this special vertical line right here? Yeah, that's the y-axis, which actually has the equation of x equals 0. Okay, so you write the axis of symmetry as an equation of a vertical line. Now, how do you find that equation? It's the same way you find the x value of the vertex. X equals the opposite of b over 2a. So pretty much, once you have found the vertex, you already know the axis of symmetry. Pretend like we did a problem and I asked you to find the vertex and it was 5, negative 1. What's the axis of symmetry? Not 5. Not negative 1. X equals 5. If I told you I'm thinking of a parabola and it's got a vertex at negative 3, positive 8, what's the axis of symmetry? X equals negative 3. Do you see what I'm talking about? Once you know what the x value of the vertex is, then that's the vertical line that goes through the middle of the graph as well. But what does it always start out as? X equals. So we already know how to find it. We just need to be able to list it. I'm going to ask you to list several things for me. I want you to list vertex, I want you to list roots, I want you to list axis of symmetry. Now, how could they test you to see that you know what an axis of symmetry is, besides just asking you to write it? Let's look at some axis of symmetry questions. Here's one I saw several years in a row, something similar to this. They didn't tell you anything about the parabola. They didn't give you an equation. They didn't give you the whole picture. They just gave you 2 points on a parabola. Now, these happen to be 2 special points. So in the setup of the problem, they said the following 2 points are on a parabola. Find the axis of symmetry. Yeah, those are the roots. Otherwise known as the what? Zeros, otherwise known as the x-intercepts. But it really could be any 2 points. The vertex and the axis of symmetry always has to be right in the middle. So what would be the axis of symmetry for this parabola? This is at negative 1, 0. I know it's hard to count from where you're sitting, and this is at negative 1, 2, 3, 4. Oh, I think I went too far. This is at negative 1, 0, 2, 3, 4, negative 5, 0. So it would be right in the middle. It's an invisible vertical line that goes right through the middle. What is the equation of that? X equals negative 3. Without knowing anything about the parabola. I didn't even know where the vertex is. But I knew 2 points on it. All I got to do is look in the middle. That's the axis of symmetry. Alright, here's another thing I've seen them do. Well, let's do another one like that. Somebody asked me, what if the roots were super close together? Yeah, what would the axis of symmetry be here? Not just 1.5. X equals 1.5. It would be an imaginary vertical line going right through the middle of those 2 points. Does that make sense? So pretty easy questions for axis of symmetry. Sometimes I've seen them do this. They would tell you, here's one of the roots, and here's the axis of symmetry. They drew the axis of symmetry in, and they ask you to find the other root. And it's not going to be a nice, perfect whole number. Alicia, y'all need to sit up. I know this is the middle of the graph. If I go left, left 1, 2, and it looks like about 2.5. That means I should go right 1, 2, and about 1/2. That means the other root has to be right there. I can't tell exactly what it is, but I can tell you what numbers it's between. What numbers is it between? Yeah, this is somewhere between 6 and 7. So just by knowing what axis of symmetry is, what it means, I can answer certain questions about the graph. Now, I am going to also ask you to list it for me in a list of attributes from the parabolas we are going to look at. We're going to do vertex and roots like we did on warm-up, and we're also going to add in axis of symmetry. So let's do one. Here is a parabola. Y equals negative x squared minus 2x minus 2. And this is what you're doing for homework as well. I want you to list the vertex, the axis of symmetry, and the roots. What's the only thing that's new? Axis of symmetry. Alright, so get busy. Try this one. Okay, so the first thing I tried to find was the vertex. Half brain, half calculator. Opposite of b over 2a, and then turn to your calculator. Look in the t-chart to find the y that goes with it. What's the opposite of b? Positive 2. 2 times a would be 2 times negative 1. What's 2 divided by negative 2? Negative 1. So I know half of my vertex. I'm going to tell my table to start at negative 1. I'm going to look at the table of values. What's the y value that goes with it? Also negative 1. So I know my vertex is at negative 1, negative 1. I already know my axis of symmetry then. I just have to make sure I write it correctly. What's the axis of symmetry? X equals negative 1. It's this x value. And you have to put x equals or it's not going to be correct. So if I were drawing a picture of it, I know I've got a grid, but I wrote all over it. If this is my grid, I know that negative 1 is my vertex, which automatically tells me the middle of the graph is right there. Now, what happened with the roots here? There weren't any. When I looked at the picture of it, I could tell right away it's not crossing the x-axis. So for roots, I would just list no roots. So these are the 3 things I want to see on your homework. I want to see all 3 things listed out for all of the questions. Alright, and one other little thing I want to show you. There's only 5 homework questions, so stop complaining. Another thing I want to show you. Look at my picture. Do you see how I'm kind of off-center? Sometimes when you guys forget to reset your calculator before you start using it, the guys before you do weird things and things get off-center. I want to show you a little trick that can get your calculator back to the normal screen. The normal screen goes from negative 10 to positive 10 on the x-axis and the y-axis. Look at the very middle key at the top. You see what it says? Zoom. The zoom key helps you zoom in and zoom out, which we will need to do eventually, but not right now. It also gets you back to normal. If I hit zoom, the normal screen is zoom 6. See where it says standard? Kind of means normal. I want to do zoom 6, and it should take you back to normal, where everything's kind of centered in the middle. You see what I'm talking about? So that's just something, a little skill to keep in your back pocket. If your calculator looks weird, reset it. Sometimes just doing zoom 6 puts it back to normal. Are y'all with me? Okay, now your homework. I'm giving you plenty of time to get started in class. I've listed all the things here I want for all 5 questions. You're supposed to list and label roots, axis of symmetry, and vertex for these 5 problems. And you've got over 20 minutes. That should be plenty of time to do these. I'll pick up homework in just a minute. You must, guys, put the calculator on your tablet. I've been giving you lots of time in class, but we will, in the future, very near future, have assignments where you need your calculator and you won't have time in class to use them. Question?